Hey everyone, this is Professor Cameron here, and what we're going to be going over today is a introduction to SolidWorks CAM. This is the built-in CAM package in SolidWorks, and what we're going to go over today is how to use this software, how to get started using this software, and why we use this software. Now, the why is pretty simple. It's to allow us to make more complex shapes easier, allow us to manufacture more complex shapes easier. Now, this is the shape we're going to be working on today, and this shape isn't overly complex. However, when it comes time to mill this, whether manually or writing the G code for this, if you were to write out the G code manually, that would be fairly time consuming. So what we do instead is we're going to run through the CAM feature in SolidWorks to generate the G code for us. Um, Now, obviously, this is about as simple as you can make a feature. So the time savings is going to be, you know, exponential when we start making more complex shapes. With more features, more milling operations. So what we're going to go over today is just a simple 2.5 axes milling operation for this piece here. Now, in other videos and other tutorials, what we'll do is go over um, pockets and then combining this peripheral milling with pocket milling, and then we'll just build slowly until we're machining more and more complex pieces. But let's go ahead and first start with modeling this shape here. To do that, what we're going to do is we're going to create a new part file. So we can select New Part File. And just like we always do whenever we create a new part file, is we set our units, and we're going to be working in inches for this. Now to start this off, we're going to go ahead and model this rectangular base. So we're going to go ahead on our top plane, create a new sketch. We're going to grab our center rectangle tool and then just draw out a rectangle. And we're going to smart dimension this to 6 by 2 inches. Right like that. Once we have that, we can go ahead and extrude this to 1/2 inch thick. Now in this example, this rectangular pad, this is going to be the chunk of material that is held in the vise, while the um, oblong cut up top is what we're actually going to be cutting. And we'll talk about that more in a second. So once we have that, we can create a sketch on this top surface here. We are going to grab our slotting tool. We're going to grab the center point straight slot option. We're going to start right at the origin and go out to the side. And draw a slot roughly that size. We're going to dimension from center point to center point at 4 inches. And we're going to dimension the radius here to 0.75. And then we can go ahead and extrude this up 1/2 inch as well. Right like that. Now, once we start doing this, and by that I mean start generating toolpaths, what you're going to have to do is start paying attention to how you're creating your 3D models. It's very easy in SolidWorks to create 3D models that are difficult or impossible to manufacture. We're going to touch on that a little bit more in the next video when we're doing internal pockets. But just something to start paying attention to is thinking about how you're going to be manufacturing these parts. So once we have this shape here, what we're going to do is we're going to go ahead and create the toolpaths to cut out this profile. To do that, we're going to go to the Solidworks CAM tab, and we're going to select Define Machine. The SolidWorks CAM tab is pretty easy to use. Essentially what you do is you start on your left and you go right through the tools, and that will generate your toolpaths for you. So we're going to start with Define Machine, and what we're doing is we're just telling it that we're going to mill on a traditional milling machine. And what that will do is that will pop up with the default tool crib, or our default tool table. Now, in future videos, we're going to go through and actually create our own tool table. But for now, just getting the hang of this default tool table will work just fine for us. Next, what we're going to do is we're going to set our coordinate system. This is when we load our part into the mill, where we would set our 0. That's what we're setting right now. So we can select coordinate system. We are going to select part bounding box vertex. What that's going to do is it's going to create this box around our part that's going to simulate our raw stock. Our part is our finished part. This box popping up here is our raw piece of stock. What we're going to do is we're going to select this corner right here, this front top right hand corner. And what we want to do is, if we notice this triad here, we want to set this to how our milling machine is set up. So we would have our X along this axis, our Y along this axis, and our Z going straight up and down. To alter that, what we're going to do is we're going to select this X axis right here and just click on an edge that is in the direction of that X axis. So we're going to select this front edge here. Next, we're going to select the same thing for our Y axis. And we're going to choose this edge right here. So that's painting our positive X in this direction, our positive Y in this direction, and our positive Z going straight up, which is what we want. So what we can do is select OK. Now, once we have that set up, what we're going to do is we're going to define our stock size. For this, we're going to go to Stock Manager. And you can see once again, it's creating that same box. Now, what it defaults to is the minimum stock size that you would need to create this piece. In our case, it's giving us a piece of stock that's 6 inches long, 1 inch tall, and 2 inches thick. That might not always be the case. A lot of times your stock size is going to be the stock that you have on hand. And there are ways you can edit this here, particularly when we start doing more complex parts. Our minimum stock size might not correlate to a standard stock size that you can buy from McMaster or another material supplier. So we can alter that here, and we'll do that in future videos, but for now, we're just going to stick with the minimum. So once we have our stock defined, we can select OK. So we've defined machine, our coordinate system, and our stock manager. What we're going to do is select Setup, Mill Setup. Now what we're doing is we're telling our computer here how the part will be oriented in our vise. And what we want to do for this is just select this top surface. What that's doing is it's telling SolidWorks that we're going to be milling straight down. And you can see this arrow here. Imagine that's how your cutter is coming into your part. So we want to tell it that our stock is going to be oriented like this, or our part is going to be oriented like this. We can select OK. Next, we're going to move to extract machinable features. What this is going to do is it's going to analyze our part and pull out all of the features that it feels needs to be machined based on our stock setting. You can see here it identified this area here as an open pocket. So this is what SolidWorks, or what CAMWorks, is going to go ahead and machine out. It's not going to do anything to the bottom because that's already the size of the stock. Next, we're going to select Generate Operation Plan. Literally all we're doing is just moving left to right through all of these buttons here. And you can see what it did is it took that machinable feature and turned it into a rough mill and a contour mill. Now, what SolidWorks is doing is it's generating a rough mill, which is going to remove the bulk of the material, and then it's coming in afterwards with a contour mill. Contour mill is going to cut it to final shape. Now we can see this briefly if we select Generate Toolpath and Simulate Toolpath. What this is going to do is it's going to generate the toolpath based on the rough and contour mill features, and then we're just simulating this going through. Now, unfortunately, it's not quite that simple. We're going to have to alter this and do a few other steps to this. And we can speed this up, and we have our finished piece. Now, like I said, we're going to have to do some things to this. What we're going to do is, instead of doing a rough mill and a contour mill, for the sake of this tutorial, we're just going to cut this out in one pass. So we're just going to delete this contour mill. To do that, we can just right-click and delete. Yes. And then you can hide that from your recycling bin if you want to. So what we're left with is just this rough mill. Now, if we run this toolpath again, you'll see it cuts it more or less to the same shape. However, if we zoom in here, do you see how it's left with this green perimeter? And then we have our solid piece. This green is material that's left behind, because when it does that rough mill, it doesn't cut it quite to final shape. That final shape is cut to in the contour mill, or the finish pass. So what we have to do is go back into this rough mill and edit some of the parameters in there so that it cuts it to the final shape. So what we're going to do is we're going to come in here where it says rough mill and right click and select edit definition. What we're going to do first is we're going to change the tool that we use to cut this with. Right now, I believe it's using a 3/8 flat end mill. What we're going to do is we're going to change it to a tool that we're a little more familiar with, which is our 1/2 inch 2-flute end mill. We're going to select that from our tool crib, and we can hit select. And then if it asks you to replace the tool holder, also click yes. So what that's going to do is it's going to replace that with our 2-flute end mill, 1/2 inch 2-flute end mill. Now in this case, it happens to be carbide. The cutters that we're familiar with are high-speed steel. When we go ahead and create our own tool table, we'll update this, but for what we're doing right now, it doesn't actually matter, and I'll show you why in the next step, what our tool material is. So when we go to the next tab here, feeds and speeds, by default, It's defining the feeds and speeds based off the pre-programmed parameters in the tool library. Now, like I just said, that's pre-programmed with carbide tooling. What we have is high-speed steel tooling. So what we're going to do is we're going to change from library to operation. What that does is that opens this up here for us to edit these parameters. So what we have to do is calculate the spindle speed and the feed rate. Now, if we remember back to manufacturing 1000, our spindle speed is 12V over pi d, or what we shorten that to is 4V over d. Now, I've done the math for us here. So our spindle speed is going to be 4 times V. V is our surface speed, which for high-speed steel tooling, cutting aluminum, is 300. So 4 times 300 divided by the diameter of our cutter, which in our case is a 1/2 inch. That's going to give us a cutting speed of 2,400 RPM. So we can go back and we can set our spindle speed to 2,400. Next, for feed rate. This is how fast the machine is moving the cutter through our part. The formula for that is feed rate in inches per tooth times your cutter speed times the number of teeth on the cutter. Our feed rate in inches per tooth, that's a setting typically set by the tool manufacturer. And for our tooling, it is 2 thousandths. 2 thousandths of an inch per tooth, times our spindle speed of 2,400, and our cutters have 2 teeth. It's a 2-flute end mill. So if we take 2 thousandths times 2,400 times 2, that's going to give us a feed rate of 9.6 inches per minute. For simplicity, we're just going to round this up to 10 inches per minute. So what we can do is we can set our X, Y feed rate to 10. Now, it also has settings here for Z feed rate. This is how fast the cutter is going to be fed in the Z direction or straight down. This has a preset parameter here of 25%. So what we can do is turn that off for Z and lead-in feed rate. Lead-in feed rate is when it first comes into our part, and Z feed rate is the speed cutting down. Z feed rate, I typically like to use a value of 2, and lead-in feed rate, you can leave that at 5 inches per minute. These values here of 25% and 50%, those are perfectly fine values. If you want to, you can leave them turned on, or if you want to manually adjust those, you can do it that way as well. So once we have our feed rate set, what we have to do is go to roughing. Now, before, it was leaving an area around our part that it didn't quite cut. That is the allowance right here. That's set to 10,000, so it was leaving an area of 10 thousandths extra on our part. We want this to cut it all in one pass, so we're going to set this to 0. Step over is how much the cutter moves over on subsequent passes, how much offset there is. In our case, that's not an issue because it's going to take only one pass. We'll adjust that in future tutorials, but for now we can leave that to 40%. For cutting method, we have the option of climb milling or conventional milling. In general, climb milling is going to give us a better surface finish. So we're going to leave that set to climb. And now under depth parameters, we have some values we need to set in here. Particularly first cut amount and max cut amount. We're going to turn off the percentage values here so that we're dealing with the depth in inches rather than percentages. Now for our machines, we're able to cut 50 thousandths at a time. So what we're going to do is we're going to set our first cut amount to 50 thousandths, and we're also going to set our max cut amount to 50 thousandths. Under NC, what I like to do in here, rapid plane, just make sure that's set to top of stock. That is the height at which the cutter is moving rapidly across our part. 1 inch over stock for this command is fine. And then clearance plane. I'm also going to set this to top of stock. And that height of 100 thou is fine as well. Once we've done that, we can go ahead and select OK. And you can see it's gone ahead and regenerated our toolpath with those updated values, with our updated feed rate and with that updated depth of cut. This has a height of 1/2 inch, so we should have 10 different cutting operations here because each cut is at 50 thousandths. So what we can do is we can go ahead and simulate this toolpath. This slider right here is the cutting speed. And this is going to simulate our cutter coming through and removing this material. Now, for the sake of our video, I'm just going to speed this up a little bit. And you'll see it's removed all of the excess material from the side. You'll still see some on the ends here, particularly on radius. This is a remnant because of how SolidWorks calculates corners. You'll see it sort of tessellates it into straight lines rather than a continuous arc. In reality, this will cut it to the correct depth on that height. This is just an artifact of SolidWorks tessellating that arc. And that is the basics of generating a outside contour feature. Now, when we do this, SolidWorks gives us approximate cut times for this toolpath. And in this case, if we check right here, it's giving us a cut time of about 59 minutes, which is what I would expect from a feature like this on the machines that we have. Now in our next video, we're going to be going over internal features like pockets, and then we'll cover how we're going to post this, how we would post this to a file that you could send to a machine. But if you have any questions on this process, please let me know. And as always, have a nice day.